Okay, logic worksheets, 9F, number 2, page 9 and 10. Use truth tables to prove these logical equivalences. Okay, so we have not P is equivalent to P. So, that looks true, but let's write it out so that we can prove that it's true. So first we're going to have a column that's just P. Then we're going to have a column that's not P. Then we're going to have a column that's not P. And then we'll just show that this is the equivalent of that. So you're just going to put two values, true or false. And then you're going to say not P would be false, true. And then not P would be true, false. Right? It would be the not of the previous one. So we can see that this is equivalent to this. So yeah, we proved it. Okay. Now we'll do the next one. P and P is equivalent to just P. So we'll do P and P would be, we'll figure that out. P and P would be true and true. So that's true. And it would be false and false. So yeah, that would be false. And we've just shown that P is equivalent to P and P. Now we'll find this one here. So first we'll do the inside the parentheses. It'll be P and Q. First we need to do a Q. So Q we're going to be true, true, false, false. And we'll extend our P column to true, false, true, false. And then we're going to combine all the possibilities of P and Q, and that's where we're going to have P and Q. P and Q are true. F and true, false and true are false. True and false are false, and false is false. Okay, so that we just figured out P and Q. Now we're going to combine that with P or P and Q. So now we're just going to combine this column with the P column. So let's see, T and T or T is true. F or F is false. T or F is true. And F or F is false. Okay, so now we're going to check. Is this equal to P? Because it says that it's equal to P. Oops, I used a different color. I used this blue color. So this is equivalent to this, right? Okay. Now we're going to do not P. We have a not P already. Except we'll just extend it. False, true. Okay, we're just true goes to false, false goes to true. And so we're going to combine not P and Q. That'd be not P and Q. So that would be this column and this column. So it would be true and false is true. True and true is true. Oh, I'm sorry, true and false is false if it's and. Oh, let me color this for you. Gray. So we're combining not P and Q. Not P and Q. So not P and Q. So false and true are false. And false are false. And true and false are false. Okay, and then we're going to do P or not P or and Q. Okay, so we're now going to do, let's see, we're going to do this or this. So it'll be true or false, which is going to be true. It's false or true, which is true. True or false, which is true. False or false, which is false. Okay? Then we're going to compare this. We're going to compare this with P or Q, right? P or Q. And P or Q is, oh, we didn't do P or Q yet, so we're going to do P or Q now. P or Q. So P or Q is true and true is true. True and, or false and true is true. And true and false is true. Or true or false is true. False or false is false. Okay, so P or Q, we ended up with true, 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 and false. And we're going to, we're going to compare that to the one right next to it. And what do you know? They're the same. So we have proved the equivalence of those two also. Okay. Now, 3. Construct a truth table for the statement P and not Q, or not P and Q. Okay. This expression defines a logical operation on P and Q, which is similar to conjunction and disjunction. What operation is it? Okay, so here's the truth table. We're going to put P and Q to start out with, and we're going to put every single possible combination of P, Q, which is true, 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 false, false, true, false, false. And then we're going to make a not Q column to figure out what that is, and that's pretty easy. We just invert each one of these, so like the true becomes false, false becomes true, true becomes false, false becomes true. So we got not Q. So now we have everything necessary to do P and not Q. So to get P and not Q, we're going to AND together this column and this column. So we got true and false is false, true and true is true, false and false is false, and false and true is false. Okay, so now we just did the left side. Now we need to do the right side. To do the right side, we're going to use not P, and not P is just the inverse of all these. So true, true, false, false becomes false, false, true, true for this one. Then we're going to take not P and it with Q. So we're going to take not P and it with Q. So that would be true, false is false, false, false is false, true, false is, no, true, where am I here? I'm doing not P and Q. So true and true is true, and false and true is false. Then I'm going to AND to, or together this one and this one. So I'm going to OR together this and this. So everything except for both false should be true. So false, false gives false, true, false gives true, false, true gives true, and false, false gives false. And now what I'm going to do is look to see what kind of operation this is. So we're going to compare this to the input values P and Q. So when both P and Q are true, the operation is false. When both P and Q are false, the operation is false. Only when one, but not the other, is true, then it's true. And does that sound familiar? It's XOR, exclusive or also known as exclusive disjunction. Okay, let's move on to 4. So 4, determine which of these are tautologies, which are contradictions, and which are neither. And so the first thing I did was I just took, we're just going to do A, C, and E, and G for these. And I'm going to just figure out what components I need. I need P and Q as the inputs, right? But we're going to process P and Q a little bit. There's a not P here, so I'm going to make a not P column. There's a not Q, so I'm going to make a not Q column. Then there is a P or not P operation, which is that one. There is a P and P operation, which is this in the parentheses. And there's a P and in parentheses P and P, which is that one. And I put these two columns for that. And then to do E, we need P or not Q, P or not Q. And we also need not P and Q, which is here. And then we're gonna put those two together. We're gonna make a and of those two, and then we're gonna put it here. Okay. And then last of all, for G, we need a not P or Q, and I'm going to put that here. And then I need a P and Q, and I put that here. Okay? So I made all these columns to do every single one of these operations in ACEG. I'm not going to explain to you, well, PQ is just true, 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 false, false, true, false, false as usual. I won't explain how to get not P and not Q because you already know how to do that. When you get the A, it's P or not P, so I am going to AND or together this and this. And when I OR them together, true or false yields true. True or false yields true. False or true leads true, and false or false leads false. Only both false is going to yield a false here. So if it's true, 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 false, is that a tautology or a contradiction? Well, a tautology is when everything is true, and a contradiction is when everything is false. So if it's mixed, it's neither, so I put an N. Okay, now let's derive C. For C, the first thing you do is P and P. So to get P and P, you take P and you AND it with itself. So true and true is true, true and true is true, false and false is false, and false and false is false. Okay? So this is an intermediate result which we need to finish C. And the way we find C is we're going to AND this one more time with P. So again, true and true is true, true and true is true, false and true is false, false and false is false. Okay? And then, so basically, true, true, false, false, this is not a tautology nor a contradiction. So that's neither. Okay? And then for E, we are going to OR together P or not Q. So P or not Q. So that would be this column and this column. And when we OR those together, we get true, true, false, true. And then to AND together not P and Q, then we're going to AND together these two columns. So true, false is false, false, false is false, true, true is true, false, true is false. Okay? And then when I OR those together, then I can get this column. So true, false is true, true, false is true, false, true is true, and true, false is true. And what do you know? This E then is a tautology, which is it's always true. Okay? Now the last one is G. For G, we're going to do not P or Q and that with P and Q. So P and Q is pretty easy. We just AND together these two columns. And not P or Q, we're going to OR together not P or Q. Okay, so everything is going to be true except for the second one is going to be false. Okay, then we're going to AND these together because we're ANDing these two together. When we AND these together, we're going to get this, which is true, false, 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 false. And this is neither a tautology nor a contradiction. Okay, so that is number 4. Moving on to page 10, 9G. Okay, so again, we're looking to see, is it a tautology, a contradiction, or neither? So first, what we started out doing is we put every single possible combination of trues and false for P, Q, and R, because those are the inputs. So the way we do that is we make the first half true and the last half false for the first one. Then for the second column, we make alternating, true, true, false, false, true, true, false, false. And then for the last column, it's really alternating, true, false, true, false, true, false, true, false. And by doing that, we have every single combination of true, false in 3 columns. All right. Now let's figure out what is Q and R. Q and R, true and true, we're just going to AND together these two columns. True and true is true. True and false is false. True and false is false. False and false is false. True and true is true. Okay, and everything else is false, right? Then we're going to OR together with P. So we're going to take this column and we're going to OR together with P. So we got true and true is true. True and false is true. Anything with a true in either one is going to be true. And everything with two falses is going to be false. So that's what we get. All right, now, are any of these a tautology or a contradiction? No, they're both neither. If you can see, neither one of them is all true or all false. Let's move on and see if we find one that is a tautology. So number 3. So we have P, we'll put true for the first half, then we'll put false for the second half. Then we have Q, we're going to do 2 trues, then 2 falses, and then 2 trues and 2 falses. You don't have to do it in this order, you can do it in any order you want to, but you just have to be organized so that you make sure you have every single possible combination. Okay, and then they want to know what not R is. Well, not R is just going to be all these inverted. Okay, and then P and Q would just be these first 2 columns ANDed together. So it'd be true, true, false, false, false. Looks like everything else is false, yeah. Then we do P and not R. P and not R. So they have to both be true to be true. And looks like only here is true and the rest are false. Okay, and then we're going to AND together P and Q or P and not R. So that would be P and Q or P and not R. We're going to OR those together. So anything that has any true in it on the left or the right is fine. So no, no, yeah, all these bottom ones are all false. So okay, so is this a tautology? No, because it only has 2 trues. Is it a contradiction? No, because it's only partially false too. So no, this is neither also. Okay. Now let's see. Can we do number 5? Let's see. Have we already done some combination of these? Like for example, we have and P and R. Did we already do P and R somewhere? P and R? No, we haven't. Okay. And then 7, we're going to do these 2. Let's do this. We'll take advantage of these tables that are already done. And we'll find P and R, and we'll also find Q and not R. So P and R, we'll just put it right here. P and R. P and R would be true, true. So most of them would be false, but sometimes it'll be true. False and true is false. False, true, false. False and false is false. False and true is false. False, false, false is false. False. Man, I'm not very good with following straight lines, am I? Okay, and so I put one in the wrong place, do you see? Okay, so for P and R, most everything is false, but there's a couple of truths. And what's the other one we need to find? We need to find Q and not R. Q and not R. Q and not R. So Q and not R. Do we have a not R here? No, we don't. Well, let's do this then. We're going to move this thing we just did here. Let's move it down to here. Isn't technology wonderful? Okay, so let's fill in this next one, which is Q and not R. Because we have not R here, and we have Q here. So Q and not R. So we'll have, we're going to do Q and not R. Now Q and not R means when are both of these true? And from what I see, the second column, the second row is, and also the third to the last row is, but everything else is false, right? So this is true, these are all false, these are true, this is all false, and this is false, okay? So now we're going to AND together this and this. So we're going to AND these two together, and we're going to put it here, okay? So to AND these together, we're looking for anything where the T's are in the same row, but they're not, so everything is false. Okay? So if everything is false, then that is a contradiction, right? So the answer for this one is, yeah, it's a contradiction. Okay? And then we're going to do not P or Q ANDed with P or R. So not P or Q. Can we do that up here? Not P or Q. Not P or Q. Not P or Q. I don't have any not P or Q's here. So we're going to have to like do this by hand then. We're going to have to start over. Okay. So let's do this. How about if we make a new table? Okay. I'll grab this. Oops, what happened there? We're going to grab this one, and we'll just copy it and make a new one. We'll just paste one down here. Okay, so we'll use this to start us off. So basically we got P, and we got Q, and we got R, and then we're going to make a not P, because we need a not P. A not P is basically just the inverse of this first column. So it would be false, 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 true, 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 true. So we need a not P. What else do we need? We also, no, that's pretty much it. Now we're going to OR together not P and Q. So we're going to have a not P or Q. Not P or Q. So false and true is true. Let's color in the other one. So we're going to do this one or with that one, right? So or means anything that has a true in it is going to be true. Only the double falses are going to be false. So if we look at the double falses, it's only those two. Everything else true. Okay? And then we are going to do P or R, which is the second part of it. And if we do P or R, that is going to be P or R, which is, okay, so if we're doing P or R, anything that has a true in it is true. Only if it's a double false, it'll be false. That's a double false. Anywhere else? Oh, there's one too. Third from the bottom. And everything else has at least one true in it. So the rest of them are true. True, 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 true. Whoa. Power on my computer just went out, but it's back now. Okay. Now I'm going to AND these together. I'm just going to AND the last two columns together. The last two columns being these two brown ones here. Okay, so ANDing those together, I'm looking for anything that is double true is true, and anything that has a false in it is false. So double trues are true, double true, double true, double true, double true. Rest is false. Okay? All right. So, and that is the answer to this one, and it is neither a tautology nor a contradiction, so we'll put N. Okay? And that's the end of page, which page is this? 10, page 10. Okay?